we're doing the dual laptop show because my laptop's at the back, and my speaker notes are on this one, and they're not going to be in sync. So this is going to be fun, but let's go for it. Right. So I've been wanting to do this for a while, talking about, I love case study presentations, and I wanted to talk about the project I've been working on. As Dave and James are in the audience, this is basically clearing up all of the wonderful stuff that they left me in Aviva. So I'm sure they'll find it very interesting to find out what we did. So set the scene, 10,000 user VDI migration. There we go. A bit of a preface. This presentation does contain AI-generated imagery. You might spot some of it, mainly because I bought a really expensive NVIDIA GPU, and I just had to kind of justify the expense somehow, and tinkering. Who doesn't love tinkering, right? And also, any kind of views in this, obviously, are on my own. They're not necessarily of my employer, okay? So moving on, hopefully you all know me. I've been around for a very long time, it feels like now. I've been working in this for 29 years. I'm now workplace architect at Aviva. I've run this thing for 17 years. God, I think that's a long time. I was Citrix CTP for 10 years until they closed down the program. And then last year, I got awarded the MVP, along with Neil and Lee. So that's all good. Right, so what you'll learn today in 4 parts, right? What we did right, what we did wrong, and what we broke. Understand some hidden costs that you might not necessarily thought about in your migration, and then maybe a bit about what we're doing next if we have the time at the end. Right, okay, checking if you're awake. Hands up if you're doing VDI in the cloud. About half of you. And keep your hands up if you're doing it on AVD. And then put your hands up if you're doing it on Windows 365. And then put your hands up if you're doing it on something else. Interesting, okay. So just getting to know the audience, right? So part 1, what we did, right? So we had an existing on-premises VDI. So the traditional stack, VMware, shared storage, persistent machines, co-located in a data center. So we had published apps, published desktops on Synapse and desktop. We also had an environment in AWS, which was a kind of a shared hosted desktop on Windows Server. Some persistent VDI in AWS as well. So it was complicated, right? Hard to manage, different user experiences, and some users basically had to go onto the one in AWS, which is internet-facing, to then access the one that was on premises because it wasn't internet-facing. And you can imagine that double hop experience, right? It's not great, right, in terms of user experience. It's costly, right? Because a lot of the users, you're hosting them twice, so you're paying for 2 lots of infrastructure costs. So it was simplify everything, migrate effectively to Azure, right? What can we simplify and get rid of? So this is the existing environment. I'm not going to go through everything, but your traditional kind of Citrix stack, right? On-prem environment, NetScalers, Synapse, Desktop, vSphere, Hypervisor, Internal Access, and then in the AWS, Citrix Cloud Broker, Citrix Gateway Service for internet access, and then server-hosted desktops, right? So very kind of traditional environments, but we kind of did everything. So business challenges as well. Performance, we have what's called ResCat 0 workloads. So ResCat 0 are effectively life critical services, right? So Aviva obviously are a pensions and investments provider, and they're also doing insurance. So if your house is burning down and you need some urgent assistance, things have got to work, right? When you call us up, someone's got to answer the phone, process your claims, sort you out accommodation, et cetera, right? So there's some life critical services that we have to provide, even if ourselves we're having a business issues with IT, right? So they're called ResCat 0. That's like the gold-plated services that we have to do. They are hosted on our platform, right? So we have to think about providing those critical services ourselves, even if there's an outage. So no downtime. It has to be infrastructure cost neutral, right? We couldn't spend any more. We had to ideally save money, right? We had a large number of disparate third parties and suppliers. So 10,000 users, but it wasn't just 10,000 of our users on our devices. It's across 80 different third parties and 80 different third-party builds, network connections, proxy configurations, you name it, right? Complicated, right? So how can we do that without messing everything up? End of support, so all the stuff on-prem, all end of life, we need to get rid of it, creaking old version of vSphere, not supported, vulnerabilities, you name it, right? So all the lights are flashing, you need to turn this stuff off, right? What can we do? In cloud, we weren't allowed to run persistent workloads, which was interesting. So how do you do persistent VDI in the cloud if you're not allowed to do persistent VDI in the cloud? Any suggestions? I'll tell you how we worked around that one. Developers with admin rights, yeah. So large developer population, a lot of them had local admin rights as well. There was an objective to try and reduce that. Obviously, it's risky giving people local admin rights, so can we do anything different? We didn't necessarily achieve that, but we'll see. So what do we do? Right. This is what we kept, and this is what we built, right? So we kept Citrix DAS, Citrix Gateway Service. So that's the connectivity, the brokering, right? Plug everything into that. And we split the environment into two. Persistent VDI for developers, Windows 365. So Windows 11, persistent, Entra native, connected to our landing zone in UK South via ANC, Azure Network Connection, managed by Intune, right? So this is the kind of like the Nirvana and modern managed cloud desktops. Everything else, so all the old XenApp stuff and the legacy and that stuff, we put on AVD. So that was Windows 11 multi-session. Active Directory joined. Some people say hybrid joined, but I think it's really just AD joined. But it's in Intune, kind of. But again, we all know Intunes have challenges with multi-session. So traditionally AD joined, right? Images were created by Jenkins and Packer. So we have a pipeline that creates out gold images. That was an established product that was already familiar in the environment. Provisioned by MCS, so we can scale up, scale down. MCS handles all the provisioning into the cloud tenant. And then Citrix handles the auto-scaling and looking at the load and determining what to turn on and what to turn off, right? So that's what we built. This is what it looks like. I don't expect you to understand this diagram, right? This is typical architecture diagrams that you see. So you've got your kind of AVD resource groups here with different single session, multi-session. You've got a resource group for your cloud connectors. You've got the image bakery subnet here where the images get created. Left-hand side are your end users. We had some users coming in over the internet. We had some users coming in over internal MPLS. All the on-prem stuff is down there. Windows 365 is kind of down here. So again, separate networks for those. So that's the kind of typical architecture that we've built. I'll be taking questions later because it's a bit of a busy diagram, right? So what we did well. Entra native. So we made a decision really early on to go Entra native. This was before anybody else in the company had done Entra native. So all the physical laptops were still on Windows 10. On AD joined. It's like, yeah, let's just go Entra native. What's the worst that can happen, right? As it worked out, it was probably a good decision. We didn't break that much. The only things that were broke were old, crappy in-house applications that assume that they're members of a domain. So it was all like in-house apps where they make a call to the domain to say, is the user who's running my application a member of groups X, Y, and Z, right? And of course, that kind of code doesn't work if the machine you're running it on isn't a member of a domain. So really, we had like 3 instances of those that broke. Go off the developers, can you fix your stuff? But everything else was pretty good. So that worked quite well. Intune managed, that was good as well. Let me just get my notes on because there's some stuff I need to talk about. Intune managed. So, Windows 365 and Intune work really well together. You can just provision them from within Intune. It's just an AD group membership. That worked really well. You can still do traditional Active Directory auth by Kerberos, right? So you don't need Active Directory to do Kerberos. You can do Kerberos either via the cloud service or you can do line of sight to domain controllers. It does get problematic if you've got multiple domains, because then you need line of sight to all of your different domain controllers in all of your domains. So then you need to make sure that your firewall rules are right, because if anything, you've got some obscure DC in some obscure domain, and it can't contact it to get its Kerberos ticket, users are going to get prompted for credentials, right? So making sure you get your firewall rules right, especially for Kerberos. But other than that, Entra native worked really well. The other good choice we made, Windows 365. Very easy to provision. It's a SaaS service from Microsoft. You add a user to a group. hour or so later, they've got a machine, right? They can log into in-tune provisions of the apps. You can have a dynamic group based on a provisioning policy, and then those applications will automatically get installed via the dynamic group, right? There's no profiles to manage, right? So it's just a local profile. You don't have to worry about FSLogix or Azure Files or NetApp Filer or all the kind of roaming stuff. They just get a local profile on the machine and log in. So that reduces your storage costs on FSLogix as well. It's built-in snapshot functionality, so you can configure hourly or half daily or whatever you want snapshots of the machine. So especially for developers, if they screw the machine up, just tell them restore from yesterday's snapshot. They can self-service that through the Windows app. That's really good. Cuts down on help desk requests. Cuts down on users corrupting their machines because they can just restore from yesterday's backup. The risk guys love this because of the whole kind of CrowdStrike risk of what happens if something happens to the whole estate. They love the fact that we can just en masse restore all of the environment to yesterday's snapshot to get up and running very quickly. So that ticked a lot of boxes in terms of our risk people as well. And again, self-service, so people can reboot, they can restore, they can reset, all via the Windows app. It's all self-service. So if you tell the users how to do it, you can massive reduction in tickets, which is great. We use quite a lot of infrastructure code and automation. So again, this is doing our AVD builds. So our landing zone build is built using Terraform. So that's all defining code. So things like resource groups, VNets, subnets, NSG rules, right? That's all done in code. So if we want to change anything, update the code, replay the Terraform, gets deployed into Azure, right? Works really well. We also automated our Citrix delivery group creation and machine catalog creation. So again, they could be included in the monthly pipeline. So when we built a monthly image with the Patch Tuesday hotfixes, that would automatically create new machine catalogs, new delivery groups with those images in for test. So again, we automated as much as possible because we knew that this is going to be a monthly process, right? You're going to have to do, and do it on multiple images because we knew we wouldn't get down to one image. We'd love to have one image, but we couldn't quite get all of the apps packaged into MSIX. So one image was unrealistic. We ended up with 5. So if you're spitting out 5 images a month, that needs to be automated, right? Wakey? We continue to use Citrix DAS. So some people said, oh, why did you continue Citrix? Why didn't you move Windows Microsoft native AVD, native Windows 365? The biggest challenge is the cost of change. So because of the large numbers of third-party suppliers, we didn't want to have to retrain 10,000 users and 80 different third parties to use different connectivity methods, a different app, different user experience, what they were used to. So we stuck with Citrix as the front end, so they continued to use the Workspace app as they had done before. All they saw was just a new icon pop up, so they could use their old stuff next to the new stuff. We could plug all the on-prem environments and AWS environments into Citrix Analytics, and also the new environments as well. And that will give us a very good before and after performance comparison. So again, one of our KPIs was don't make it worse, right? And then we can prove that, okay, we've not made it worse. This is the logins today. This is the logins after we've migrated, right? And that was gold dust when you're going back to the business and they're saying, well, people are saying it's slow. You can immediately look at the data and say, hold on, they're saying it's slow now. The logins used to take 4 minutes, right? So having that visibility across old and new environments was really, really useful. Yes?
Was that still related strongly to the 18 MSPs also? The change you needed to
Yeah. So because the technology change was so big, we didn't also want to have to do a technology change on the end user as well, right? So we were changing a lot in the back end, but what we wanted to do is make it seamless for everybody else. So they could continue using the Workspace app. We didn't have to get new firewall rules or all that kind of stuff that you would need to do to change over to Microsoft. Stick with Citrix. We didn't need to basically tell them we were changing anything, right? Other than at some point you're going to get a new icon appear, and that will be your new desktop, right, that you start using. Obviously, Citrix is multi-cloud, right? So we could have our on-prem, AWS, and Azure all aggregated into one for the user. The URLs didn't change, so it was very seamless, right? So migrations for the users was very, very easy. Something else we got from Citrix is Uber Agent. Again, that provided the application level performance. So you could look at applications that maybe weren't performing as you expected, And then that's got a mine worth of data, right, in Uber Agent as to all the information you can drill out. It is expensive in terms of the Splunk costs. Obviously, Uber Agent needs to send data and store it somewhere for the reporting. The Splunk dashboards are amazing. Our Splunk team lost their shit when they saw the amount of data we started to send them. It was like gigabytes a day from the environment. But so if you can manage that cost, Uber Agent is definitely worthwhile investigating. Right, that's the highlights. While I get myself a drink, any questions on part one, what we did? Part two, what we did wrong. So we're not perfect. No one's perfect.
Neil,
Yes?
I'm assuming for any AWS functionality, you had to extend all of your existing domains into AWS. So you were putting domain controllers in AWS?
We weren't, actually.
Can you explain that then?
Yes, so because of our cattle pet policy, so we're not allowed persistent workloads in cloud, it meant that we couldn't build domain controllers in cloud. So effectively, we were consuming our domain services from the on-prem domain controllers over the link from AWS, right? Not ideal. I would like domain controllers next to my Windows workloads, right? We have the same. We had the same problem in Azure, right? We couldn't build persistent machines in Azure in our subscriptions to run domain controllers, right? I fought like crazy to get it, but in the end, it's like, no, you're not doing it. And that was part of the reason we tried to go intra-native, right? To kind of remove that dependency on on-prem domain controllers. So the much we can do in intra-native, the less reliance there are on AD. So no group policy, right? No let log on shares, all that kind of stuff goes away. Just a bit of Kerberos floating around, right? Which is quite light.
Did you get figures on the increase in ingress-egress costs then based on domain controller traffic?
I could get figures, but
I'll be
we didn't. Yeah.
Because this is one of the things.
But the traffic was negligible compared to the rest of the traffic, basically. So, right, what we did wrong, right? Come on, part two. Wakey, wakey. There we go. It wasn't quite that bad. Pick your delivery partner. So we didn't do this ourselves, right? So we partnered up with some third parties. I'm not going to name any names, but there was a few false starts, right? Because they didn't either have the capability, they didn't really understand what VDI was. They were cloud experts, but cloud experts might be native cloud. They don't really understand VDI. They're very different beasts, right? So there was a few false starts in terms of getting the project off the ground. So pick your delivery partner wisely is the first one. This one might seem like common sense, but it wasn't always part of the project initially. So know what you have, right? So if you're going to move a load of stuff somewhere else, you kind of need to know what you're moving. And if you don't know what you're moving, you're going to get into trouble, right? There's a lot of shadow IT. Developers install their own stuff. How do you know what everyone's been doing, right? They've had a persistent VDI for like 3 or 4 years, with the local admin rights. They've got all sorts of shit, right, on there. And then we're going to pick it up and give them a brand new shiny, VDI in Azure. And then it's like, well, where's all the stuff I've been, installed the last 2 years, right? So knowing what you have is important. Obviously, there's apps that can do that on scan your estate, give you reports on stuff like that. There's like Lakeside. There's all sorts of tools that you can get. That wasn't spec'd in the project, and I think that did bite us a little bit because the more you don't know about, there's more kind of they'll trip you up further on, right? When you give a user a new VDI, they start testing it. It's like, well, where's all my stuff? We didn't know. We didn't know you've installed all this stuff, right? So that's important. Know what you have, and know what you need, right? So again, what do developers need? Do they need 4 core, 8 core? What size SKUs do you need in Azure, right? How many users are you going to get on your multi-session VDIs? Are you going to use V5, V6, V7? Are you going to use SSDs? Are you going to use RAM cache? There's in AVD, you've got so many buttons to tweak, right? So many little knobs you can tweak, different SKU sizes, different number of cores. You can obviously go for fewer larger machines or more smaller machines. Where do you start, right? It's like, well, here's like a whole bunch of, it's like a big playground. Here's cloud. You can provision anything you like, right? So it's like, well, okay, well, where do we start, right? You've got to start somewhere. And that can be like quite overwhelming. And it's easy to get wrong, right? You've got ephemeral disks, you've got SSD disks, and it's changing, right? So from the life of the project, what you started out with, and then 18 months later, when you actually start to deploy it, technology's moved on. You've got new SKUs out. Maybe they're cheaper. Maybe they're more performant, right? It's a constant catch-up game. So again, knowing what you need is really tricky because, again, business requirements change. So try and define that. You might have to spend some time testing it, do performance testing, use the EUC score benchmarks that are out there to compare the different SKU sizes in Azure. And define what good looks like, or at least know what bad looks like and avoid it, right? So how do you know that users are getting a good experience on your new platform, right? What metrics are you going to use? Are you going to use logon time? Are you going to use time to launch applications? What does good look like, right? Disconnection per day, per user, availability of the platform. There's a whole bunch of KPIs that you could use, right? But you need to define them at the start, measure them in your existing platform so you have a comparison, because otherwise you don't know if you've made it better or worse. And then obviously then measure it going forward during your project to make sure that it doesn't get worse as you add users. Define that deployment strategy. So how are you going to get your apps onto the VDIs? This has always been one of my big pain in VDI, because one size doesn't fit all, right? When you've got an image based in AVD, you might want to try and sideload in some apps via MSIX, but maybe you can't package all your apps into MSIX. You've got options like Winget, Chocolatey. You've obviously got Intune managed for more persistent workloads. Have a strategy to say, if this is the workload type, this is how we're going to get the apps on, right? What criteria are you going to use to put apps in the image versus sideload into MSIX, right? Is it the number of users? Is it the criticality? Do you want to how many applications do you want in that base image? So have all that defined at the start, because then you've got some rules to play by as you go through the project. You might change the rules as you go, that's fine, but at least have them written down so you can give guidance to your packaging teams and all the other teams. When all these application requests start coming in, you know what to do with them, right? Do they go into Intune for deployment on Windows 365? Do they go into the pipeline for installation into the gold image? Do they go and package into MSIX for side loading at logon time, right? You've got lots of different options, and you need to define what's going to work for your applications. Sensible connectivity strategy. This is called when is 6 firewalls too much, right? So we're all obsessed with security, right? If you look at how our environment is users connecting to the apps, right? So this is their desktop on the left-hand side. You've got a software firewall in Windows, right? Then in Azure, you've got an NSG, Network Security Group, which is another software firewall. Then this is a hub and spoke design, right? So in the hub, there's an Azure firewall. All traffic has to go through Azure firewall to get anywhere. Then if you're coming on-prem for your application, so this is an application in AWS, actually. So this example. So it goes on-prem. So to get on-prem, you have to go through a firewall at the end of ExpressRoute to go on-prem. Then you've got direct connect and egress firewall to go out to AWS. Then in AWS, you have an AWS NACL to say what IPs can talk to my application in AWS, right? That's 6 firewalls just to get your user connected to your application, right? And okay, you might have less than this, but a lot of large enterprises, they have this many. And they're all managed in slightly different ways, right? So, your Azure firewall might be managed by Terraform. Your Windows firewall is GPOs or Intune. And then your sort of network firewalls might be Cisco or AlgoSec, something like that. So if you want to connect A to B, you've now got to go to 4 different places to see, do you have rules for that connectivity, right? That's time-consuming, and it's very easy to get wrong. So, if you miss out one, sorry, I can't connect to my application. And then you go, well, where have we failed, right? Where did we drop that connectivity? That adds time, that adds complexity. So again, be aware of that. We could have chosen to do a kind of a wild card, everything can connect to everything. CISO shut that down pretty quickly. It's like, no, we're not having anything in cloud connecting to everything on premises. That's just not going to happen, right? So then you need to understand what are your application connectivity requirements, right? You've got maybe 1,000 apps. What do they all connect to? Do you know? How did you find out? because you've got to build some kind of NSG file rule, right, to match all this stuff. Again, that adds time, complexity, and cost to your projects. So think about that. Okay, this is a little bit of a case study on something else that went wrong in our environment. We're getting into the weeds now of networking. Are you ready? Ready for some weeds? Yeah, okay. This is a lesson on how not to configure Azure Firewall if you don't want to do self-denial of service via IDPS. So who knows what IDPS is? Nobody. Great. This is IDPS slide. I had it ready. Okay. Intrusion detection and prevention system. It basically looks at all the network traffic flowing through Azure Firewall, inspects it for bad stuff, right? It's part of Azure Premium, right? Azure Firewall Premium. Looks at all your traffic. Any bad stuff, it's like, no, I don't like that. That's malicious. And Microsoft maintained this massive database of they said 67,000 in 50 categories. It's probably got bigger since I did this slide. So all the bad stuff that can be floating through your firewall, it drops it out, right? You think, yeah, that sounds like a good feature. Let's turn that on. Something else that we use Azure Firewall for, and this will be relevant in a minute, DNS proxy. So if you've got multiple domains or multiple domain controllers and multiple DNS servers that service DNS, you might want to use Azure DNS proxy on your firewall. What that will do is it'll look at the DNS request that's coming in, and it will send it by a lookup table to one of many different DNS servers, right? So it might be internal, one of your internal domains. If you've got multiple internal domains, you can configure them. And then everything else kind of flows through to internet DNS servers, right? In our case, that was Infoblox. And you can configure that called DNS proxy. It's just a turn-on feature in Azure Firewall. Quite a good feature to use, we think, because we have a lot of internal domains. So we've got users on the left, working away, make a DNS request. DNS request comes into the firewall. Yeah, that's all good. Goes to my domain controller. Works great, right? Different domain, goes to a different domain controller. Yep, that works great. No problem there. If it's an internet, goes through to the internet DNS server. So everything's working great, right? DNS is working. Someone opens a slightly dodgy site that has malicious content on, right? IDPS doesn't like that, so it blocks the DNS request altogether. Now, so that request never gets made to internet DNS. It's just blocked by the firewall. So what happens? Azure Firewall thinks, hold on, this guy's not responding, so I didn't get a response to my DNS request. So it puts him in the naughty corner, even though it was blocked by IDPS, which is a different module on your firewall, right? So DNS module, IDPS module, right? And one traffic flows through the other. So this guy is now in the naughty step because he didn't respond to my DNS query. So what it does, it sends it again to the next one. What do you think happens next? Exactly the same, right? So now all of my internet DNS servers are in the naughty corner, and no one else is responding. And what happens without DNS? Not a lot, right? Okay, so you've now created a denial of service, right? Yeah, don't forget your bypass rules, right? So in the IDS service, there is a page where you can say bypass list, and obviously configure your critical services that you never want to get blocked, DNS being one of them, right? You might want to add in others there, like internal file shares or destinations that you know are safe and you never want to get blocked by the IDS. We learned that the hard way when one person took out the whole DNS for the whole estate, right? Just one person visiting one dodgy site. The firewall just blocked all DNS. And it's always DNS, right? That's the... OK, lesson number 2. Here's another one. Another self-denial in the service. This time, it's by another Azure Firewall feature called... Actually, it's an Azure feature called DDoS protection. Everyone heard of this? Yep, know what it does? Yeah. So basically, how it works is you have your traditional hub and spoke network, right? So you've got a hub where your firewall sits, and then your spoke virtual networks is where your workloads sit, right? So VDI is in one of the spokes. Azure Firewall sits at the hub. Same thing like the Express Route Gateway sits in your hub for the on-prem traffic, right? And what DDoS service looks at, it looks at the amount of traffic going through your public IPs, right? So if you're getting a large amount of traffic into your public IP addresses, it then stops bad people doing bad things to your internet IP addresses. So, I keep going in the wrong direction on this thing. So this is kind of how we get to the internet. So you've got a lot of VDI clients, 10,000-ish, right? They're all connecting to the internet via a cloud proxy service. Cloud proxy service uses a UDP tunnel. So your traditional kind of Zscaler type, method of getting to a cloud proxy. You have an agent on the machine that gets tunneled through Azure Firewall, out through your public IPs, over to your cloud proxies, and then onto the internet here, right? Same thing, DNS, right? DNS goes out by UDP from the firewall. All hunky-dory, right? It's all working great. UDP tunnel, backwards and forwards, great performance, until some kind of peak of traffic here, right? That tips you over the threshold of that public IP address. So, and the thresholds auto-scale in Microsoft, right? You can hard-code them if you have a problem, but Microsoft don't like doing that. They auto-scale, they look at your traffic paths, and they do have a maximum, right? Even if you configure them at the maximum, you can still trip it, right? And if it's tripped, the only way, well, there's two ways, actually. The two ways you know it's tripped, you get one counter in Azure, which is 0 or 100, that says you're being DDoSed, basically. It's a DDoS counter, it goes to 100, sits there whilst it's blocking the traffic, and it goes back to 0. The second way you can tell is all your stuff starts working, right? So now, this public IP address has hit its threshold, the DDoS protection has kicked in, it's now blocking all incoming UDP traffic to that IP address, right? So what do you think is going to happen to all these connections from my cloud proxy service that's coming back into my environment via UDP? Any suggestions from the audience? Yeah, that stuff's going to break, right? But we have multiple public IP addresses, right? We've got lots on the firewall. So what happens is the firewall decides, oh, this one's not working anymore. I'm going to send them all to a different one, right? So now you've got even more traffic going through a different public IP address. What's going to happen next? That's going to trip the counter as well, right? Because that's not even more load going through it. So effectively, this is like a cascading failure across your public IP addresses. And now effectively, everything breaks, right? Because you've just got no incoming UDP at all. DNS is now broken because DNS also uses UDP. That doesn't work either. You've denial of service yourself as well, right? So don't do this. The recommendation is, don't use Azure Firewall for your egress traffic, right? So Microsoft recommend using that gateway. When this was designed, Microsoft designed this to use Azure Firewall as the egress point for all traffic because it's part of a standard landing zone. We've learned the hard way that that's probably not the best way to do this. So I'll talk a bit more about NAT gateway coming up. Is that clear how that happened, right? Yeah. And because the DDoS protection service is a multi-tenant, multi-customer service provided by Microsoft, you can't have allow lists, right? You can't say these IP addresses are safe, because they might be safe to me, right? But other customers actually say, well, actually, they're not safe. So there's no allow lists or bypass lists for this, right? It's just on for everybody, and you just have to suck it up, or just turn off the feature altogether, right? But you probably don't want to turn off the feature.
Was that on the DDoS standard feature that Microsoft provided, or did you subscribe to the Azure DDoS premium service above that?
I'm guessing it's premium.
Right.
Yeah. And if it's premium, we probably bought it, right? Because someone bought the hype from Microsoft, and that would do everything we wanted to really well, right? So yeah, I would imagine that's premium. I don't know what the differences are actually on that service, but.
Have the client considered using firewall appliances from the vendor that they use on-prem to keep things consistent?
No, not really. It was just like, Azure Firewall, that's standard. It was a Microsoft reference architecture, right? So hub spoke, firewall in the middle, spokes off the edge. All these could try that. Right, I need to move on because I'm going to run out of time. Lots to talk about. So cost management. So cloud is expensive, right? Who doesn't know that? Everyone knows that, right? Not cheap. Let me catch up with my slides on here. I'm way behind. Just making sure I cover everything I want to. Something we found in cloud, something called Double Defender. So in cloud, you've got like Defender for servers, you've got Defender for endpoints, you've got Defender for everything, right? And what we found in our standard landing zone, they had a policy that says, we want all workloads protected. So there's a policy that turns on Defender for every resource in cloud, right? Sounds like a good thing. It's like, so you've got two plans, $4 a month or $14 a month. You've also got something called Cloud Security Posture Management, which is free, yay! No, it's not, that's just foundation, that's like basic stuff. If you actually want to do anything, it's $5 a month, right, per resource. So this got enabled everything. And when you start to drill down into how much your virtual machines are costing, right, there's a headline price, but then you can get a breakdown price of everything underneath it. And we started to see that, hold on, we've got Defender for servers in here, but these are Windows 11 multi-session machines, which are running Defender for endpoints on them, which we get as part of our E5 or E3 license, right? So I was like, well, effectively, we're paying twice for all this stuff, right? And okay, it's like £3 a month, £1 a month, right? Times that by the number of VMs you've got in cloud, and it's expensive, right? So just be aware of that. This was coming down from a higher policy in Azure. It is for servers, right? These aren't servers, but Azure doesn't really care about the difference. If there's a policy that says subscribe these to Defender, it will subscribe them to Defender, right? Same as Defender for endpoints. So again, you get Defender for endpoint plan as part of your E3 or E5. So if you've got that, just use the endpoint version, turn off the server version, so you're not paying twice. Network pairing firewall and egress costs. Right, so what's this about? We all know networking is free in cloud, right? Surely someone said that once. No? So this is your typical reference architecture, right, for this kind of stuff, right? So you've got, your network gateways, you've got, gateway hub spoke model, all your desktops out here, and you've got some storage over there, right? You've got SKUs of Azure Firewall. Beware of the capacity limits on the SKUs. So if you've got in standard, you can do up to 30 gigabits per second. If you want to go over that, you need the premium, which is up to 100 gigabits per second. Be aware how this works. The way it achieves the throughput, it's effectively is a VM scale set, right, behind the scenes. So you start with a small number of machines. I think it's a minimum of 2 or 3. And effectively, it scales up and down as load changes, right? By provisioning more machines and adding them to the virtual firewall you get. Problem with that is, what do you imagine happens when you provision up and down a scale set to persistent RDP connections? They don't persist, right? You get disconnected. That's not a good thing. So bear that in mind. If you've got Azure Firewall and you're sending RDP traffic through it, users will get disconnected unless you've hard-coded the number of firewalls that you have. Right? So if you turn off the auto-scaling and you have a fixed number of firewalls, and even then, users will still get disconnected because Microsoft still patch these things, right? And you can't stop that happening. They're running some kind of Linux. Microsoft apply updates to them. They do get rebooted. That is disruptive. There's nothing you can do about that. You can set maintenance windows when Microsoft will do that. There's an option in the firewall to set a maintenance window. But again, if you want a 24/7 service with no network downtime on real-time traffic, you can't do it with Azure Firewall. NAT gateway, yes. Azure Firewall, no. Right? Sorry, mate? Oh, yeah. Don't get me wrong, I love I hate Azure Firewall. So bear in mind the throughput, bear in mind the scaling. So things to make. Cost as well, right? So Azure Firewall standard. So you see what my throughput is, 50 terabytes a month, right? So we are sending a lot of data through these things, right? Remember, 10,000 users. So this is about $1,700 versus about $2,000. So the base cost, is $900 versus $1,200, and obviously the data processed is the same, $800, right? So actually the premium isn't that much more expensive, and you do get like a lot more throughput. Optimized configuration. So this is the way Microsoft now tell you to do it. It's like, don't send your traffic through Azure Firewall. That's a terrible idea. Use a user-defined route for things like RDP and send it out through a NAT gateway. It's especially more important, if in Azure they're turning off the default outbound access for new VNets. So if you create a new VNet, you don't get internet access of it anymore. You have to send it out through either Azure Firewall, a load balancer, or NAT gateway. So Microsoft now say, use the firewall as your default route, but override that for RDP, right? And you get a much better experience. So this is kind of like a work in progress for us because that guidance is quite recent. And building new NAT gateways in a large landing zone is not exactly simple. So NAT gateway is more expensive than Azure Firewall. So a dumb network appliance that all it does is switch the IP address Does nothing else. There's no IDPS, no DNS proxy, no filtering, but it costs you more. I'm just leaving that here. I don't know why. I don't know why. It costs you more. Same traffic, right? Same uptime, same things. It's more expensive than the premium version of Azure Firewall. Microsoft are little greedy buggers, aren't they? Anyway, and don't forget your bandwidth, right? So we egress a lot of bandwidth. That costs money, right? So this is like, I think, 55 terabytes, 50 there, something, lots of zeros. Yeah, so don't forget your bandwidth. Other costs, right? So this is a quick snapshot of our landing zone costs, right? So Azure Firewall Premium, $5,000. Express Route, 10 gig, $5,000. RTM preference, that is the internet egress onto the Microsoft gateway network, I think. $3,000. Virtual network peering, so this is just like connecting your VNets together, right? Subnets together, $2,500. Log analytics, right? All this log data you're ingesting and reporting on, that costs you money, it's not free. You've got application gateways, you've got express route gateways, you've got another express route circuit which goes the other direction, which they charge us for again. Public IPs, DNS, and policies on Azure Firewall, right? So, you know, all that is expensive, right? So don't forget all of the kind of hidden networking costs from Azure. Part 4, I'm just about on time, so I'm doing really well. So what's next? So one of the challenges we have in our environment is complexity. AVD has a lot of moving parts, so can we simplify that? Again, I think Ryan's covering more of this afternoon, so I'm not going to go massively into depth in terms of the analysis, but we are looking to say, do we need all of this complex build mechanics, all the knobs to twiddle for AVD? Can we just put everybody on Windows 365, right? So self-service, give them a machine, persistent VDI. We don't have to worry about anything else, right? So that's quite appealing. Obviously, it's more expensive, so, you know, but that's one of the things that we're thinking about. What else are we thinking about? Let me bring my notes up very quickly. Less VDI. So, you know, 2 or 3 years ago, things like enterprise browsers didn't really exist, right? And if we look at our kind of users, right, they're usually from third parties. They're usually not employees of our company. So, you know, how many of the workloads that we give a VDI to today can we just say, here's an enterprise browser, right? Just log into a browser, do your work. Even looking at like the Office suite, right? Can we give them the lesser Microsoft license that only gives them Office Online, not the full stack, right? Is that going to be enough for them to work? Because that's going to be a hell of a lot cheaper than, you know, a full E3 or E5 license and you know, an AVD or a Windows 365 machine they get today, plus all the software that we have to license inside it, right? So that's an exercise that we're going is, you know, how much of our estate or our workloads can we deliver via an enterprise browser style solution over the internet, secure browser, DLP controls, right? The DLP is important. That's one of the primary reasons why we do VDI, right? It's that segregation of environments. They can't take our IP out. They can't copy and paste it, you know, all that kind of stuff. Enterprise browsers now have that capability. So can we, you know, can we move more users? So can we actually use less VDI? Okay, so key takeaways. Hopefully you've got all this. Know what you have. Define what good looks like. So what you're trying to get to. How do you know it works? You know, have you ticked all the boxes of your project? Be aware of all kind of the networking gotchas, these like denial of service stuff that you know, no one really thought about. Choose the right SKU types for your workloads. So do you go persistent VDI? Do you go AVD? Again, there's other presentations on that, so I'm not going to cover that in depth. And again, be aware of your hidden costs. So with that, my final AI-generated picture, which I really love, I'm done. Any questions on that? That's been a very quick whirlwind storm, but if not, oh yes, there's one there. Yes, sir.
How did you retain remain cost neutral while keeping Citrix? Have you just gone through a renewal and you were locked in?
Yeah, so we already paid for Citrix, right? So that kind of didn't really come into the equation because we're already using it and we're going to continue to use it. The cost neutral came from most of the getting rid of the on-prem stuff, not having to pay for things like vSphere license, shared services, data center hosting costs, right? So the cloud part was more expensive, obviously, because cloud is always more expensive, but we weren't paying for it twice, right? We weren't paying for it AWS and on-prem. We were just paying for it once in Azure. So in terms of the overall solution, it was actually cheaper. You can obviously take out Citrix if you want to for reduced costs, but again, that would have a cost of change for us, so we'd have to then embark on a big new project to then remove Citrix as well. Yes, sir.
How well did the forecasted cost for the variable stuff compare against?
Completely wrong. Completely wrong. So Microsoft gave us a nice spreadsheet of this is how much will everything cost based on SKUs from about 3 years ago, right? And the actual costs were like completely different. So, yeah.
You mentioned earlier on that one of the requirements was to not have any persistent machines in cloud.
How did I get around that? How did I get around that? Very clever. Good question. So Windows 365 is provisioned into the Microsoft tenant, right? Because it's a SaaS service. So I put a nice argument to say we're not provisioning any persistent VDI into any of our landing zone subscriptions. There'll be no persistent machines. AVD or ephemeral, they get turned off when they get reprovisioned when they powered off. All the stuff, all the persistent stuff, isn't ours to manage, right? It's a SaaS service. It's in Microsoft tenant, Microsoft subscription. They manage it. So that's how I got around that. So we did do persistent. Yes. So it was really a kind of a play on words, but they accepted it, right? So we weren't provisioning persistent machines into our landing zone or into our tenant, right? It was all in Microsoft subscription. So that's how we got around that. Yes, one.
Do you have any issues with any older applications that exist on the estate, things that are on the client server that are a bit chatty?
Yes. Yeah. So some applications, there's some crappy access databases. I even found some, I don't know, there's one app that had a copyright of 2003 in it somewhere. So when we stretched them out from on-prem into Azure, it performed horribly, right? Because they were sitting next to the backend database or whatever it was, access database on a NAS or something like that. There was some also software that was running from the NAS. There was like a folder full of X's and all that kind of, the usual legacy IT stuff, right? So some of the stuff did break. Some of the stuff, the business either had to find a different way of doing it or accept it was going to take longer if they didn't retire their app and find a new business process, right? So what used to take maybe 30 seconds now takes 2 minutes, right? We put that problem onto the business to say, okay, it's now going to take 2 minutes. You need to fix whatever process that you do wrap around that. Either, you're going to factor that into the equation of it's going to take longer, or you're going to have to re-platform your app or re-architect or retire it. So we gave them options. We did spend a little bit of time see if there's a way that we could optimize it. But ultimately, if it's really chatty and you're stretching it from 2 milliseconds to 20, it's going to be worse, right? And there's no easy fix to that. We have one use case that stayed on-prem, which was Blue Prism automation stuff, because they were kind of doing their own thing, not really VDI, and they just had too much stuff that was going to break if we tried to move it. So we just said, this is your stuff, you manage it, we'll leave it there. And we just built them some kind of traditional IaaS on-prem for that. Everything else got moved. So I'm aware that I'm holding you from lunch. There's one more question, one more.
Are you running Windows 11 multi-session in both AWS and Azure?
No. So there's nothing in AWS anymore, right? So it was server multi-session in AWS. That got migrated out onto Windows 11 multi-session in Azure. And then, obviously, the Windows 365 is single session, right? So we only have 2 flavors of Windows 11. Windows 365 single session, AVD, Windows 11 multi-session. Everything in Azure, nothing in AWS, nothing on-prem. Project complete. And now it's lunchtime. Thank you very much.